Alright, so I'm going to get you guys started on your homework. Now remember, your homework was Unit 5, Lesson 10. And you guys were doing 1-3 with 6 with extra credit. So again, at the bottom of your page, you should be able to see Unit 5, and then it should say Lesson 10 for reflections. Right, it should match. Alright, so I'm just going to demonstrate a couple of the more difficult ones on number 1. Okay. So remember, the line y equals x is the diagonal line going through the origin with a slope of rise 1 and run 1. So I'm modeling right now the idea of 1c. Okay, so this is y equals x. Right. So in order to get this point reflected across this line, it's easy enough that you can actually just count the boxes. So it's 1, 2, 3 boxes diagonally. So you go 1, 2, 3 boxes diagonally onto the other side. So there is where your point A from C should go. All right. So we'll call this A prime, A double prime, A triple prime, and it gets to be complicated. So I'm going to just do A to the 4, A to the 5 prime, and then A to the 6 prime, instead of trying to make 6 hash marks. Okay, so this point right here would be the one that came from C. Okay. Now we're going to do y equals negative x. Okay, so again, now remember, y equals negative x would be through the same origin, but going down 1, right 1, so it gives you the diagonal line, but in a different direction. So to be able to reflect that point across the blue line, which again, this is the one from D, of y equals negative x, we can do the same thing. Because remember, it's going to be perpendicular. So if this is going down 1, right 1, down 1, right 1, down 1, right 1, we need to do that to get to the boxes on the other side. So essentially, I'm going down 1, right 1, okay, which is back. So that's 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5 to the other side. And that's where A4 would go. Okay, so again, it's easy enough that we're actually just counting the distance across to get to the other line. Okay, now here comes the tricky part with some of you guys. The x equals 4 cannot be put into the graphing calculator, but x equals 4 is simply going over to where x equals 4 and then drawing that vertical line through it. There's E. Okay, that's apart from E. So again, just count the distance. It's just a straight line, so it's really 1, 2, 3, 4. So you count across 1, 2, 3, 4, and there's where your A5 would go. Okay. Same way as how we would do y equals negative 1. Y equals negative 1 means go down to where the y equals negative 1 and draw a straight line, this time a horizontal. And that would be part F. So again, apply that same theorem. Count down till you get to the green line, see how many boxes it is, and then repeat on the other side. So that should help you with 1. Now just please finish it and write all those coordinates that they're asking you for. I did not model the x and y axes. That should be easy enough for you. If so, if it's not, please ask questions in class. Alright, on to 3. Now it wants to know how this was reflected. Well, we can pretty much eliminate the x-axis. If I was to reflect this over the x-axis, the distance from here to here is only 1, so it would only be 1 above and D would be here. It's not, so therefore it can't be that. And if I was going to reflect the A, B, C, D over the y-axis, B would be 1 to the left, so I would only go 1 to the right. So we can clearly see that the B prime's not there. So it leaves us with these two. Okay. Now, let's take a look at what the y equals 2 and what the x equals 2 looks like on our graph. Right? Y equals 2 is this line here. This is y equals 2. And then we can see what x equals 2 looks like. This is the line y equals 2. Right? X equals 2. And y equals 2. So I want you to use your brains and think, does it look like it flipped over the pink line, y equals 2? Or does it look like it flipped over the green line of x equals 2? Right, that should be more than enough help for number 3. Right, now we'll start sum of 6, but not all of 6. Okay. Now remember, number 6, it wants us to reflect it across to a line. This is the line y equals negative 2/3 x. Now remember, to get from here to the image on the other side, you can either use a sheet of patty paper, which might be your best bet, or you can use the idea that they're supposed to be perpendicular to one another, which means that I would take this slope of negative 2/3 and make it perpendicular to 3/2, which means from each of these points, I'm going to go up 1, 2, 3 and right 1, 2. I only had to do that once to get to the line, so I'm only going to do it once to get to the other side of the line. 1, 2, 3, 1, 2. There's P prime. Now I'll count and see how many times it takes me to get M to this line. 1, 2, 3, 1, 2. That's once. 1, 2, 3, 1, 2. That's twice. So that means I need to go twice on the other side. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Right? We can find where M prime goes. I'm going to do the same thing for N. See how many times I have to use the slope to get to the line. Once. Twice. I had to do it 3 times, so now I'm going to do the same thing 3 times onto the other side. That's once. Twice. Here's where N should be, N prime. Okay, and we can test that with patty paper to make sure it does indeed work. Let me trace the image first. Then I'm going to trace it with the patty paper just to double check. Here's my image. HW.mp4. Fold it along the line of y equals negative 2/3 x. So I'm going to fold this over and make sure I'm still lined up. And as you can see, I'm pretty much right on top of it. It lines up with the triangle that I drew underneath. So it lets me know that, yep, I did the reflection across y equals negative 2/3 x correctly. Right, so from here you guys should be able to give the coordinates. Now remember, if we're talking about y, they must have the same area. You're going to want to mention something about the words rigid motion. So remember what you're doing and why we call it a rigid motion. Okay, so I'm going to leave your homework help as that. If you have any further questions, please see me after school or in class.